Okay, so this time I wanted to do a very quick demo of UFO-CFD, the original Cartesian version from scratch. So I've got here an STL file called Bunny. When we load that into ParaView, it looks like this. So it's been oriented with the x-axis as if there's flow going from left to right. So this is quite a fine model. There's lots of triangles, and so for whatever reason we might want to do a CFD analysis of that. So my working directory, basically I've got the text input file, got the GUI, and I've got the solver. So load the GUI first of all, read in the text file with all of the default values, and then I want to select the bunny geometry. So I first of all type in bunny there, and I've got a Tmax value of 66,000. So I'm not sure if that's going to be enough, but I'll press wire, and there's the bunny. Number of tries 66,000. I'm not sure if that has read in all of them, so I'm going to increase that, and I want to zoom in a bit, so pressing Y just redraws it. So there's actually 69,000 triangles in that. So it's slightly off center, but that doesn't matter. I'll just zoom in a bit more. Oh, it's disappeared. Okay, so it's quite a small geometry, which is why I've had to zoom in quite a bit. So the next thing I want to do is these other options here that just fills the triangles instead of having a wireframe. We can wipe the screen, but I press cage and that calculates the extent of the domain and then updates the x-min and x-max values over here. So I think I still need to zoom in a bit more in order to see the mesh size. Alternatively, I could just scale the model up. ParaView. So if I press mesh, you can see that the mesh size is really large. So I need to decrease this quite a bit. Quite large. I'm just reducing the mesh size a little bit each time. Okay, I mean that's still quite coarse, but it's adequate for a demonstration. And Now I've got 20 cells expanding outside of the uniform region, so I might want to increase that to 10 cells. Okay, let's have a look at the live point. The live point is nowhere to be seen. I just need to reposition that. That should probably be okay. And so that seems to be the mesh sorted out. Got a CFL number of 0.3, some default smoothing values, ball function 1, beta 4, low velocity, tangential, Adams bash forth, time stepping. I might want to have a lower velocity, so I've just set like 10 meters per second. It's set to 1,000 iterations now, saving after 1,000. So that's mostly set up, I think. So I can just save that, and that is literally just writing the input text file. If we go to this, all the GUI does is write this text file according to the settings that we've just specified. So just to make it a bit easier for setting up the mesh, really. Now I can run that. So I'm just going to go to the working directory, which is going to run it. So it generates a mesh within a fraction of a second and then runs straight away. I mean, the meshing time is insignificant. And in this case, it seems to have diverged. So let's just stop that. I'm going to set the iterations to 0. Rerun it, then load it into PowerView just to check the mesh. The domain seems to be in the right sort of area. That looks okay. Probably just diverged because there's not enough mesh away from the geometry. In which case I could change the CFL number a little bit. Change that to 1,000 again, and then rerun it. Thing to keep an eye on when it's converging is the maximum velocity in the domain, which is 16. So that's always going to be about roughly twice your free stream velocity. And the maximum wiggle number. So this is going to be 1%, 5%, 10%. But when it starts getting any larger than 10% or 0.1, then there might be a problem in the solution. So it's done about 500 iterations already, and it's still running. The maximum velocity is 15.7. That looks okay. And the other residuals seem to be reducing. And this is running in parallel. On 4 processors. So it's making good use of the CPU. And that's writing the solution quite slowly because this is an ASCII file. And there it's done. So we have a look at the convergence, which in GNU plot. So after 1,000 iterations, we see things converging nicely. It's not quite converged yet, but it's getting there. And so then we can load that into our view. Take a cut plane and look at the velocity. Velocity around the bunny. Have a look at some streamlines. Have a look at the distance field surface. And switch the original geometry off and look at the distance field. Got the velocity on the surface there. I just move that back a bit. There you have it, and that's a flow solution in UFO-CFD.